Hopefully everybody can hear me all right out there, wherever you're tuning in from. Welcome to the Princeton Review's AP Physics Review. So today's a very special session, live streamed, coming at you from, well, personally, Tallahassee, Florida. We just had a nice band of storms roll through, so things are nice and soaked. But more to the point, we're live streaming today because we're trying to cover all these different changes that the College Board has thrown at us here. Fortunately, they've thrown at us, right, because there was big discussions as to whether or not they'd even hold the test. But they're definitely showing up and making sure that all the effort that you guys have put in will still, make use of it this year. Considering we have all the tools we need, we just have to adapt on the fly, right? So today we're being live streamed, like I said. So we're going to be covering things a little bit at a different pace than you might have experienced with the Princeton Review before, or as you might experience in the future. So normally we'll be interacting much more in real time. We'll be transferring questions from YouTube over to the course room that we're working in. So some of the very quick back and forth questions I might have about the arithmetic will be more streamlined, and me flowing and guiding you guys, and then you guys kind of giving me your more bird's eye questions. So we won't miss the forest for the trees today at all, that's for sure. So I know a lot of you probably have a lot questions just surrounding the test, and maybe some of you have been doing your homework more than others, but College Board has been really good about providing information. So maybe I'll just be a filter for you here in the beginning. So again, we're covering the AP Physics 1 exam today. There's going to be a few more physics sessions as the weeks roll on, so you'll probably see additional material covered today. There's probably more information coming as we go. So any specifics or any dates that change will be covered in future sessions. But as far as content, which would be like the second half of our day today, we'll be kind of dipping our feet into kinematics and some basic stuff surrounding Newton's laws, just covering that mile-long, inch-deep nature of the test, keeping in mind that we're taking a different test. So we're going to spend some time talking about how that test is different in May versus other years. And currently the plan is to go back to the way things were with the test as of coming next year. So this will just be for May 2020 currently. So as you know, you can put questions into the chat and they will get to me somewhere within like 30 seconds or so as we keep going. But let me give you an introduction to myself, and you'll have to forgive us. The slides are going to be coming in real time at you, so I'll be blowing them up here as we go, because this is all brand new information. So my name is Will Tucker. I don't know if I've introduced myself just yet. I've been with the Princeton Review for far too long. It's been over a decade. I wouldn't say too long in a good way, right? So I'm a tutor and a teacher. I've been working with them originally for MCAT sciences surrounding chemistry, and then eventually biology and physics. And from there, I just decided to hone all my test-taking abilities and the love of assisting other people with doing better on these things that seem so difficult, but just require a little patience and practice, right? Perfect practice. So I started working with GRE, GMAT, all the SAT and AP tests, the DAT, the OAT. Does this cover AP Physics C mechanics also? Not today. It would be tiresome. The emails just keep coming. All right, so let's go ahead and talk a little bit about the test, because I know that's what you guys really want to see something about here, right? Like, what gives already? What did they do to us? For those of us who haven't been paying attention, right? So what happened was in March 2020, right, we had the COVID thing go down, and many schools had to shut their doors, right, for the spring 2020 session. So naturally, we hold our AP test there. So what are we going to do? College Board, who administers this whole thing, said, well, we're gonna step up for the students, the ones that put the work in, because many students that were pulled didn't want to cancel the exam. So a lot of this information here actually came from a webinar, which you can download on College Board site. They went a little bit deeper as to their impetus, like why they're doing what they're doing. So they decided, the delivery platform is going to be online, because, I mean, how else would you do it at this point? And we want to keep all of our accommodations for disabilities in there, so that if that was already on file for you, that will automatically be reflected towards exceptional timing circumstances on your online test. Now, they also were aware that not everyone has access to the perfect device for what they need, for what they need to do here. So they have a website set up, cb.org/tech, where you can get involved with ways of acquiring devices if your schools haven't been able to help you already. So I'm not sure to the extent of that program, but they seemed pretty adamant about utilizing it. So I have hope. As of the last meeting that they held, 22 states have formally agreed to honor these AP tests for this May 2020 session. So the general thrust here has been that states are enthusiastic, like school systems, right? Colleges are enthusiastic about still honoring, even though it's a unique administration, they believe that the scaling will still be useful and representative of success. So they did note that security was a high priority here, because the last thing they want to do is put the test online and then everybody's proctor takes it for them or their tutor takes it for them, right? So we don't want that, and they don't want that. So they have very sophisticated methods, let's just say. That's what they said. There are some methods they can disclose and some of which they cannot, but they have many metrics on you already. And if you think you can get away with having someone else write your test for you, you're probably sorely mistaken. I would not test that beast. So one thing that is different is they understand that they can't keep you from having an open book test at this point, right? So even though that formula sheet was provided to you, you have Google, et cetera, et cetera. So they've gone out of their way to choose questions that are not represented, that are, these questions are being screened to ensure that the information is not readily available online, because they understand that a quick Google search might get you to some sort of balancing center of mass situation that's common on the internet, right? And so you might just be going there for your theory, and that's the last thing they want. So that's a difficult one to predict as to how the questions are going to be affected due to that, right? That sample size, that bias. But they are providing practice to you. So let's talk a little bit more about that practice and what resources are available. So let's see here. All right. So first of all, big thing to note about the test that's being offered here in May is that it will have no multiple choice section. Okay. So as somebody who loves tests and test preparation, that just hurts my heart, because that's my favorite sort of it's the easiest logical reasoning to get ahas on. So it means we're going to be entirely restricted, and for good or bad ways, or in good and bad ways, right? For some people, this will be a pitfall. For others, it'll be perfect because they already liked to think this way. So we're being limited to our free response questions. Even on top of that, we're being limited to 75% of the content. So modules 8 through 10 that were normally covered in AP Physics 1 will no longer be covered. So if you were looking at a different AP Physics test, let's say looking at Physics C test, you might have similar considerations. What you'll want to do is you'll want to go to the coronavirus resources that the College Board has prepared. So if you go to this website here, the apcentral.collegeborg.org/courses/AP-physics-1, you'll find a bunch of, first of all, you can find those practice prompts. So some of the new practice questions that are indicative or representative of the new test, right? Or what the test is going to look like. So you can kind of get a feel for that right from the horse's mouth. But you'll also find information at this site about some of the changes to the test and ways in which you can prepare beyond just a practice test. So I've got some of that information that we'll go over here in a minute, but I want to make sure that you guys have access to it, because some of the slides, some of those tables that I prepared came in a little blurry, so I'll kind of be talking them out, but I also expect that you guys go to the website and are actually looking at the plethora of resources that College Board has provided. So if you have specific questions as to how this thing's going to be administered, like how am I going to write it and upload it and connect to this new entity, right? This new platform, that will be all found on this apcoronavirusupdates.collegebord.org/students/taking-AP-exams link. Okay, and so this is pretty much essentially like a guide, right? It's like your user manual for doing this online. So that's your how-to. All right, so more on the theory. Again, we're only covering modules 1 through 7 now for this test. There's going to be 2 free response questions. You're going to be able to view this stuff on a desktop or a laptop or your phone. So you don't, taking the test on your phone might seem weird, but you're probably writing this test anyway, right? You've been doing that. So remember, your phone can take pictures, and that's legible enough for a grader, right? So it's maybe more important than ever that we are very legible in our writing, depending on, how nice our phone is that's taking the pictures. But again, the resources have been made available as we were looking on the previous slide. So make sure you're taking advantage of everything that's out there right now. So you can type it if you want, but obviously with AP Physics, I doubt you guys are going to be, maybe you have a Wacom tablet or some sort of tablet device and you're writing on there. If you do so, you can save that as like an image file and you should be just fine. Okie dokie. So they will be providing 5 minutes for all uploading of all AP tests. So no matter what time you see mentioned, you can tack on 5 minutes that's spent uploading it before it moves to the next question. All right. So let's look a little bit about the dates that have been released so far. So what we know about when the test is. Okay. All right. So this is going to be blown up a little bit here, but you can find this on the AP Physics websites. I mean, for all of the AP tests, they put a schedule up, and you'll notice for us, where we're at over here, algebra-based physics. Let me highlight that. So we're looking at Thursday, May 14th. And they've got all the different time zones that you can come up with, but let's just look at Eastern here. It'll be held at 4 p.m. Okay, so it's kind of late, but it's not going to be that long of a test. As you'll see, it's gotten a lot shorter here. So let's bring in some of the specifics about. Well, first let's talk once more about resources before I get off this stuff. Let's talk about resources that College Board has provided to us. Additionally, aside from all the what's changed and the specifications, how can I get better at this new test? How can I learn more about what is, right from the horse's mouth? What does College Board have to say about the changes? What are they doing to prepare me? Well, you have online live classes that are being offered at the level of College Board as well. And so you can find those at that similar AP Coronavirus Updates page under the AP course schedule link. They also have a YouTube channel similar to what we're doing here, where you'll have live classes that you can orchestrate, figure out your schedule thereof for the AP test that you're taking. So I've kind of just put a few in here for Physics 1 that are remaining. Fun fact is you can go back and view these live streams. The recordings are all up. So the stuff that's already occurred that you've missed in the past 2 weeks, it's all up there ready for you to find, so make sure again that you are utilizing your resources. There is a lot for you to handle. Take bookmarks, keep your bookmarks organized, because this it's pretty impressive actually, the amount of organization that College Board has managed to incorporate in such a short time. So again, these are recorded classes that College Board has put out. You'll find them on the YouTube channel. You'll find links, and for ones that are coming up tomorrow, there's gravity. Wednesday they have some energy stuff. Thursday more energy stuff, and then Friday simple harmonic motion, which I believe oscillations are approaching the latter material here. We'll come in just a second as to what's still on the test, given that we're only using 3/4 of the material. But more on the specifics of the test, like the actual structure of it, this new test, okay? Because they did give us a little more information. And forgive me, these are my blurriest slides, I promise. So what we have here are they put the dates up again, so you're not missing much. Oh, let me get this. You're not missing much here. Stuff we already talked about. Here's the important stuff. So talking about the timing. So you have 25 minutes, okay? 25 minutes for question 1. Remember, this is 2 free response questions. Question 1 will account for 60% of the weight of the grade. And the type of question, well, they're naming it a qualitative quantitative translation question, a QQT. Essentially, it's looking at how well you can translate between, again, qualitative and quantitative justification and reasoning. So this one's going to be a bit more algebra heavy, with also, the emphasis on the why. So why am I using this equation? Why did I choose to put my equations in this order? Why does this inform that? So making sure that you're very organized in your algebra and your math there and being complete. All the normal stuff that we're about to talk about soon that apply to free response questions, that's going to be as essential as ever. The second question 2, so after question 1, you'll have your 5 minutes to upload, right? After you've uploaded that, you'll get 15 minutes So altogether, we're talking about a 40-minute test here, with 2 5-minute uploads. It's only a 50-minute test now, pretty short. Question 2 will be 15 minutes, and it'll take up 40% of the score as far as the weight. So this is going to be a paragraph argument short answer question. So this is making sure that we understand conceptually and can talk about physics using the right words, using the right justifications, right? Just to show that we know what we're doing here. So a lot rests on this one question, and you only have 15 minutes to work on it. So I imagine, remember, this is graded on a curve, so you will have, you're in the same boat as everyone else, which should give you some hope that you're not at a necessary loss just by taking it right now versus waiting a year or for having done it last year. Okay, so you got some more information there. Just a few more specifics that they have provided regarding the test. Obviously, you can find all this information again on College Board's website. Shouldn't change at this point, I imagine. They've gone through this much effort to make it so, and we've got about a month before the test now, a month and a day. So you can look at the units that are going to be covered here. Right, units 1 through 7. They're not including units 8 through 10. So we'll talk about those units. And they have some information regarding, what tools are still available to you. So calculation should be done on pencil and paper with no calculator. They said, you're allowed to use one. Obviously, now that you're on a computer here, you're going to be just, it might as well just be careful that you're accustomed to using your computer's calculator, and that, one of your buttons isn't sticky or something that's not going to, because you've been eating too much at your desk. And so you don't end up having calculation errors that are just due to, using some new form of input. If you have another calculator, you might as well just go with what you know. Now, notice there are makeup dates, right? So you have June 2nd here for individuals that are not able to take the test on the May 14th date, at least for the AP Physics 1. So here it would be at 2 p.m. on June 2nd. All right, so let's go into the content a little bit, talking about what is going to be on the test and what is not now. So from the content side of things. Oops. All right, so here's the original breakdown of the units, right? So we had, we usually, have a certain amount of exam weight, meaning the probability that you see questions relating to this, or that they take up that much of the room of, say, the multiple choice section. Right now, we're only dealing with 2 questions. So it's a bit odd to be talking about, the weight. I look at this as maybe like a probability function of the likelihood that I see a question related to one of these things, right? But we do want to note that units 8, 9, and 10, these have been removed, right? So these are removed from the 2020, from the May 2020 session. All right, so I'll just go ahead and, maybe put some blocks over that, just so you guys have, just so you guys, I want you to be able to see it, but know that it's not there, right? So these things, if you see topics related to this, these are not possible topics for your short answer questions. So don't worry about digging back into those. All right, so that at least, you can kind of divide your percentages up as you need there. But your guess is as good as mine as to where those percentages go up. I mean, my guess would be energy. My guess would be kinematics. My guess would be simple harmonic motion, right? These tend to be very useful topics, simple harmonic motion in terms of being able to test waves at this point still, because they don't have waves on there, but they do love waves. So, oscillations were the closest that we had to that intro material. So if they want to, derive from that side of things, they'll probably go that angle. But they could, very hard-hitting subjects, energy and kinematics always fly. So we're going to go with the old rubric as far as the scoring of this, we assume. We don't assume there's any changes here. So what we say is, and a 5 on the AP Physics 1, very low percentage of people are usually given this on the curve, right? So this is where essentially like an A for your GPA credit. 4s, a little higher of a percentage, and you can see that correlates to specific scores at different schools. And then 3s generally get you that passing score. Anything under that, you're probably not gonna, you essentially don't get credit for. So you're kind of aiming for these 4s and 5s, right? I know you guys know AP. Nothing's changed there. Okay, nothing's changed there. So I should probably mention that also, speaking of nothing's changed, if you were scheduled to take the test, if you were registered to take the test, you're still registered to take the test. So they've automatically ported this to online. So you don't have to do any extra effort there. Your coordinator doesn't have any extra effort. There's not much your coordinator can do right now, right? So that's worth noting. All right, so let's get into the meat and potatoes today. So we're going to be looking at what topics, back to our basics, what topics are covered from a bird's eye view, right? So this is our generic list here. I'll be noting what things we can remove, right? So we still have kinematics, right? We still have essentially where things are, where they're going, how to map their trajectories. We still have Newton's laws, F equals ma. We'll be talking about these today. Circular motion, so centripetal forces. Remember, a centripetal force is not, it's like an F net, right? It's not an actual force. You have to plug in for it. Simple harmonic motion, like I said, that's probably a hot topic. I believe I was looking at the practice test question they put up for the short answer, and if I remember right, it is a simple harmonic motion question. So I have been primed a little bit there, but you guys can go over there to the AP or the College Board website and get that and start working on it. It's important. Momentum, obviously, with collisions, work and energy, right? This is a big topic, so definitely pay a lot of attention in work and energy, right? It's important to be able to utilize scalars. And obviously, throughout all of this, unit analysis, right? So it's not mentioned as part of the course content, but trigonometry, utilizing units, utilizing proportions. These are things that always come up with physics, right? So we want to give them credit where it's due. Make sure that you're as good at that as ever, because you're having to show what you really know in only 2 questions. So you need to really hone your ability to work with the trig and your ability to be organized in your math. It's going to be essential. All right, so rotational motion, dynamics. Now notice here's a few things that we can get rid of, right? So electrostatics are not on the May 2020 test, right? Nor are the mechanical waves and sound. Okay, so we can take out a few of these. If you remember, there's like big ideas. There's like 6 of them technically. I think we have a few, broken out here, which I'll bring up in just a second. All right, so these big ideas relate to the whys. So why do we want to study physics 1? What are the goals the AP has for us? So they want us to understand why systems, to understand first of all that systems have mass and charge, have structure, and then how to utilize that structure to make predictions. So they want us to look at fields. They want us to understand forces and free body diagrams, and then how changes in these systems or how interactions can cause changes such as electrostatic force or gravitational force. I see no questions yet, so you guys must be inundated with information right now. I know, so don't worry about it. As we go through the content, you can always ask questions, and if you want to email me with any questions specific to the test, stuff that you didn't quite get the first time, feel free. All right, so conservation is obviously a big concept. So understanding the before and the after should be the same if we're dealing with conservative forces. That has to do with energy, right? Waves. So this is where you might find that this stuff is not a big idea currently, right? The transfer. I still think that's a big idea and important, that waves are a transfer of energy and that they are just out of phase oscillations, right? The medium is not moving, but the wave is. The wave is the energy. The medium's oscillating. So I think that's still important, and you're going to need that for the oscillations, right? Just maybe not taking it all the way. But most of this stuff still holds weight. All right, so it's worth mentioning. All right, last thing I'll mention about resources and bird's eye view for content is going to be the resources Princeton Review has for you. So you can go to our website, or you can go to Princeton Review's website or the College Board's website. But if you want to look at Princeton Review's resources, we have a lot of practice problems, etc., exam resources that that's Princeton Review's biggest shtick, honestly, is the quality of their review, the practice. We're all about perfect practice at the Princeton Review. So we have the AP student, the AP website, and you have the Princeton Review. Oh, Justin's asking, what type of collisions do we have? energy conserved. So that would be the elastic collisions, right? Just, I mean, it's kind of off topic and niche, but it's worth noting. Yes, it's collisions, so things where there is, I would think of it this way conceptually. There's no energy going into my internal system. It's all just between me and the object, right? So I didn't internalize any of the energy. It didn't disappear on me. What we usually think of as our prime example for conservation of energy is like friction versus frictionless. So if I have an ice skater or something moving on ice, I think of, I give it a push and it just keeps going and going and going. But if I pushed it in the real world on the pavement, it stops pretty quick, and that's because there's energy being lost. It doesn't just get to go. It gets eaten up by the system internally, and then it goes away, and now things aren't moving, right? So you can kind of think about these things conceptually. Obviously, this would not be the exact wording you'd be writing in your paragraph. This is the thinking that we're doing, right? We have to be much more systematic with our terminology, and that's why we practice a lot, so that we can see the most concise way of saying something that is correct. All right. Cool. Thank you for the question, Justin. I appreciate it. So I always like actually getting into some real content here. Speaking of real content, let's first discuss how you would approach these freestanding questions, right? So specifically the freestanding questions that we're doing, but how do we approach these? What are the common tactics that Princeton Review and I would recommend when doing these things? I know I've been alluding to them a bit already, so I'll try not to belabor too much here. Okay, so first of all, when we have the free response questions, we have goals or tactics, right? Things that we have to do every time, and have to do them a certain way. So we need to always be justifying our arguments. So this could be, again, we have two different questions here. We have a question that is, what happens in a perfectly inelastic collision? So I'll reserve some of the specific questions of momentum and stuff to actually, I believe it would be next class, the next time the live stream is being held, because we're getting kind of nitty gritty in the content there. But it's not a bad question. Your question is what you have to know going into the test. But it will be covered in the momentum stuff. So that'll be covered after the dynamics, after Newton's laws and stuff. All right, so back to the overview of tactics. So things that you have to do, and when you do them, you have to do them a very specific way. So justifications need to be supported by evidence. That evidence could be, conceptual principles physically, or it could be, an equation or a relationship or proportionality, all of which would need to be shown mathematically, right, and put in the right place at the right time. So making sure that you're justifying your answers, you're not just hand waving, as we say, and just showing that you got the answer correct, right? You'll lose points that way, lose possible points. You'll make sure that you want to show your calculations, including the units, right? So units are important, and on the AP test, with the short answers, they do like to see the units to make sure that you're tracking the right conceptual variables, and that you're aware that you're using the right conceptual variables. Don't just jump into bigger equations that rely on previous equations. So if you have some, let's say that you're utilizing some sort of, like, I want to find the speed of something as it falls a certain amount of distance. And so I have this, v equals the square root of 2gh derivation that I have of one of the kinematic equations. Don't just use your derivation. Start with the big 5 and plug in appropriately, even if some terms zero out. So start with your fundamental equations, which are on the equation sheet that's provided to you with the test, right? Essentially, this is kind of like a little vague here, but this is really just going back into the idea that in order to get all the points, you're not just going to be right, but that you're going to show all of the work and all the thinking that one would need to show in order to be fully correct. All right, so something that it's not only easy to follow and your way of doing it, but a way that is universal. So that's why it's kind of like why we use SI units, right? A very specific. We won't want to use grams out of nowhere when equations call for kilograms. That we're all speaking the same language. Okay, so in that regard, what are some pieces of advice I could give you? I would say, oops, this is a list we've had going here, but be aware of pacing. This is a really short test now, right? So being aware that you're in a 25-minute question and that you only have 5 minutes left. It's important, right? Because that's going to change what your value system is as to what you need to get done. So make sure that you're practicing, and that when you're doing your practice, you're doing perfect practice and keeping a timer and making sure that you're remaining within that timer because the game has changed a little bit here, right? We're going to, again, justify our answers, clearly explain. I've been over that, right? You use only the space you need. So this is a good way to train yourself, like a fighter that trains themselves in a very specific area, because if they leave it, they've kind of lost ground and they're relying on other tactics. So you kind of know that if you can't fit your answer into a very specific size block, you've probably written too much, right? So maybe not so much with the first one, but that second paragraph where you're given the second short answer question, where you're given 15 minutes. I mean, how much can you write in 15 minutes that is well thought out? Okay, so keep that in mind and make sure that when you're practicing, you're limiting yourself to, a single paragraph when it asks for a single paragraph. That's important. Always go back and read the question. That's advice I'd give you on any test, even if we were in multiple choice questions on AP test, right? For the AP physics, make sure you're reading the question. The question, it's easy to read a question and think you know what it said. So make sure you're going back and always, cueing yourself with the question stem. Common sense. I wish that, a bullet point is never enough, right? Common sense will be found through your perfect practice. You'll have aha moments, and you'll realize that you've been maybe going out of your way and doing things a little bit more difficulty, with a little bit more difficulty than was necessary. So those are great teachable moments. That's why we practice. So make sure you're practicing. And of course, have a meta mindset, have a Socratic mindset, be able to think not only like you when you're practicing, think like you, the test taker, but then be able to grade yourself like a grader. And then have the mind of Socrates to come back and say, how am I going to actually change the behaviors of that test taker such that they will conform? So this is things like, using only the space we need. So setting yourself up for, in this perfect practice for success. And then, being reasonable and saying, I don't know the answer after the fact. How am I going to change my behavior when I don't know? How am I going to lead myself to the fundamental concepts that are being tested here? Because I'm smart enough. I've studied this, right? I know most of us get done with a problem and we go, we read the explanation and we're like, we knew that the whole time, right? But why couldn't we figure out that's what we needed to do? That's going to come through practice and leading yourself to the answer, using the question stem, and then using some constraints. Thinking before you write. So this is this is really important here. You might want to utilize some scratch paper just to organize your brainstorming. That can help your thoughts of this leads to this equation informs this, and once I know this, I know that I'm using a positive y-axis in the down direction, so that needs to be stated. I need to show my axes. So you can kind of set up your plan of what is your goal, what has to happen. I'll go ahead and type it in here. I don't know, so you guys can relay it to the chat room over there. So William Dustin Tucker, Dustin with a D, William with two L's. I think they're all that way. William Dustin Tucker at Tucker with a T at gmail.com. Gmail is in Google, our lovely overlords, right? Okie dokie. So that's the why that's the how we do. We've been over the why and the what's. So let's start talking about some of the content that you're going to see on test day. Okay, and I'll be passing the torch as we go to these other live streams next week and moving on. So today is going to be a very brief introduction to the kinematics and to Newton's laws, some of those dynamics. All right, so just as a bookend here, so our slides have our recordings that we download from this will have some thoroughness to them. If I'm reading them after the fact, we'll be talking about, again, kinematics to start off. All right, so, and again, I understand that you guys can't give me the interaction that I usually know and love so much, where I could just ask you a lot of pointed questions. So I'll have to work with that. But right off the bat, whenever you encounter kinematics, you have to get your terminology correct. Because as we know, speeds and velocities, distances and displacements are not the same thing, right? Very particular terms. The important distinction is one of them includes direction. Okay, we call those vector quantities, right? So I'll just go ahead and note that here, that a vector quantity has both a magnitude and a direction. Okay, and that's important. It means if we ever think about an instantaneous quantity, such as the instantaneous velocity or the instantaneous acceleration, we usually assign it an arrow, right? We give it an arrow when we draw it, that points to a direction, right? And we can relate that to the X or Y axis, the number of degrees, and utilize our trigonometry, etc., to break it down into X and Y components if we were to do such a thing, right? So this is kind of bringing back everything you've known and loved, right, that you probably haven't seen in a second. But we're right back at it. So the displacement, this is our first big term, first important term, because it's the easy one to mess up. A displacement is an object's overall change in position, and it is a vector quantity, right? And it's kind of like just the straightest line, right? The shortest distance, if you will, between 2 points, the start and the finish. So let's say that I had an actual trajectory here. I started at my room this morning and I made it over to the bathroom. That was my finishing point, right? So the actual path was convoluted, right? This would be essentially the distance that I traveled. Okay, it actually has a length to it, right? And in lengths, we measure in meters, right? That's our SI unit for distance there. Now, I've actually also traversed some displacement here. My displacement is not quite the same as my distance, though, because again, my displacement is going to be the shortest line, the shortest distance. So a displacement might look something like this. Okay, so my displacement is essentially the shortest line. Oops, I don't want to write with such a large pointer here, but this is my displacement. Okay, so again, the displacement's just the overall change. Notice I made it into an arrow there. I gave it a direction because displacements are, again, vectors. Okay, so it's not the total distance, right, of the trip, right? But it's not actually how many steps I walked. It's just the overall change in position of where I was to where I was going. Now, notice most times in life, I'm going to be looking for the distance. I'm going to try, in my normal life, I'm calculating trajectories. When it comes to MCAT, though, I tend to be working in displacements. I tend to care about only the overall change. This is because most of the time when I'm working on questions involving kinematics, I'm thinking about something falling, and I'm thinking about only its change in energy in relation to the center of the Earth thanks to gravitation. Okay, there could be other scenarios where my actual path matters, like when I have friction involved. So it really depends on the force that's acting. It's just that most of the time when we're doing kinematics, we're only worried about the gravitational force. So it'll really depend on the scenario and the forces that are involved. Okie dokie. So let's kind of like think about a generic situation where we might have a mix-up between force and displacement. If I can get this to make me a new slide. There we go. Sorry about that. So let's say we have a runner. Runner's taking a lap. Okay. They start and finish at the same point, right? They're running once around the track then, and we know the total distance is 500 meters. Okay, for the time for what they just ran. So first of all, I'd have to think about what equation informed that, right? So that total distance in this case would have come from the circumference, right? That was a circumference. And if you remember, the equation for the circumference of a circle, right, was 2 pi r. So I could actually figure out the radius of this track if I wanted to, if I was so inclined, right? But I won't be so inclined today. Now, what I need to notice is that even though this runner had ran the circumference of 500 meters in one lap, the displacement for this lap, since I started and finished at the same place, right, the displacement must be equal to 0 meters. There was no change in position. Okay, so I have a question here from the class. If an object were to fall from the height y from the Earth and move towards the Earth due to gravity, does kinetic energy increase as the object falls and gravitational energy decreases? You're almost on point there, so close. So I would agree with you, right, that kinetic energy increases. I could write that. I would say kinetic energy of the object increases. I could also say the work done by gravity on the object is positive, right? We'll get to work eventually, not today, but eventually you get to work and you can talk about the direction of or the positive and negative nature of work and how that affects the energy change. The one thing I would change here is I wouldn't say the gravitational energy decreases. I would specifically say the gravitational potential energy of the object changes. So objects can have systems, right? Can have potential energy, and when they're working with conservative forces, they can have potential energy and they can have kinetic energy. This happens in a spring block system as well in oscillations. In that case, we call it the elastic potential energy, right? So it's key that we note the type of potential energy, and then we note that it's potential and not kinetic. So that's kind of the dichotomy here, right? With conservative forces, that's the whole idea of conservation of mechanical energy, right? Is that no matter what I started with in kinetic energy and potential energy for that given force, I need to end with. It can just change hands. So if I started up high, yes, I lost potential energy as I fell. But as I fell, I was gaining kinetic energy, right? And the way that I measure potential energy is through height and a few other terms, right? But not important right now. I measured it through height and that decreased, whereas the speed increased for the object, and that's one of the terms that comes up in kinetic energy. So yes, good way. I like that you're not missing the forest for the trees here. It's good that we do that, especially with that second question, because we have to really frame these things from a high level to make one paragraph describe a whole situation and to use the right words. So again, the important thing here that was weird with this example was that we had, sorry about the example numbers here. I didn't have a chance to clean that up. But yeah, this is our first example here. You didn't miss two other examples, those of you just tuning in. So the big thing here was that the distance was 500 meters, indeed, but the displacement was 0 meters because we started and stopped at the same position. There was no change in position. All right, so how useful is that? Not very useful in that case. But again, in physics, if you were to start and stop at the same position, or as far as the displacement from the center of the Earth, I would expect no changes in your energy here, apparently, from what we're discussing. So maybe there are some uses in this. All right, so that could let me say something about your speed, etc. if I came back and started talking about things from a kinematics angle. So let's keep going with this. And remember, there's not just a juxtaposition between displacement and distance. There's this difference between speed and velocity. So the speed, remember, you hopefully remember, was the total distance, the change in distance, if you will, over the change in time. So you covered, let's say, 50 paces, right? Paces are not SI units. Let's say you covered 30 meters between here and the bathroom, right? From your room to the bathroom this morning when you went to take a shower. But let's say you did it in like 20 seconds, right? So you could figure out exactly how many meters per second you were traveling, right? So again, SI units are important. Now, the difference between a speed and a velocity, right? They kind of have the same concept, but the velocity also includes a direction. So it's not just, first of all, it includes a direction. That's not the only thing that makes it different, okay? Because remember, if it has a direction, it's a vector. So by virtue of being a velocity, by being a vector, it has a magnitude as well as a direction. And also important is that it is including the displacement. It is the change in the overall position over time in some dimension, right? In some one dimension. So it's the shortest straight line between your start and your finish. Therefore, right, since the speed was including distance, it was essentially just a magnitude, okay? And because it's relating speed and velocity relate distance and displacement respectively, we're going to necessarily have differences, right, in some situations, because the displacement and the speed are not always going to be the same, as we just saw, right? Like when we were in that loop, or in that making that lap. But again, it's still meters per second because we're still traversing some length over some time. All right. So let's go back to that runner for an example here. Oops. So with that runner, let's assume that the runner in the previous example completed the race in 1 minute and 18 seconds. Okay, so we could find the average speed as well as the magnitude of the average velocity, right? Remember that previous case example was just one lap, right? Just one lap. But for the speed, it should be easy enough, right? So let's go ahead and look at the first part of this and talk about the average speed. Okay, well, the average speed here was, we covered 500 meters, right? So this was let me just go ahead and write the definition out here for us so we don't forget that and have to go back. So the speed, again, was a distance over a time. We already said the distance in one lap was that circumference, right? So that circumference is going to be, it was told us to be 500 meters, right? That was 500 meters over the time here. Now the time says 1 minute 18 seconds. I have to be careful. Some of you are probably thinking at home about units right now, and you're saying, well, the SI units for time need to be in seconds, right? Not in hours or minutes. So when I convert this, I need to remember the unit conversion, that there is one, in 1 minute, I have 60 seconds. And if I wanted to, I could, add that to this. It might be a little more verbose than I need to be. I could probably just assume here that 1 minute 18 seconds will be understood as also being 78 seconds, right? So I can look at this as 78 seconds. Now I have 500 meters over 78 seconds. So I just do 500 divided by 78, right? And I get some obnoxiously long number. And it looks like I got about 2 significant figures here. So maybe I'll just go with, it's around 6.41 meters per second here. Okay. So again, that was the average speed. Now, some of you that are more clever out there might have already come to the conclusion about the average velocity. So remember, given that the velocity is going to be a displacement over a time, right? And since we started and stopped at the same position, right, this is essentially going to be 0 meters for the displacement over those 78 seconds. And as you know, 0 divided by anything is still going to be 0. So this is 0 meters per second. Interesting, interesting. So again, notice that the speed and the velocity do not need to be the same. And sometimes, and oftentimes they're not. Just like the distance and the displacement have that same problem. So now we can kind of ask ourselves, and this would have been more like, so far this would have been more like the quantitative justifications of how we know what we know, like that first question. But the second question tends to be more like paragraph infused, right? So let's ask ourselves, is it possible to move with constant speed with not constant velocity? And then is it possible to move with constant velocity but not constant speed? Oh, these riddles, right? These are just riddles. So first of all, in the first case, right? Well, is it possible to move with constant speed but not constant velocity? Well, let's think about the differences, right? So a constant speed let's just say this. Constant, I'll kind of write it out with you so you can get a habit of this. Constant speed implies a constant magnitude of velocity, right? Now, that does not limit one important part of velocity, right? Well, so we'll note that this does not impair the ability to modify velocity's direction or to change velocity's direction. Okay, so because it is not impairing that, then we are able to change direction. So you could essentially have the same speed, the same magnitude, but just constantly change the direction. Some of you that are more astute might be thinking, yes, that's uniform circular motion, where I'm only changing the direction, right? So you could essentially put here, e.g., uniform circular motion, or UCM, right? So in these cases, we have changes in the velocity, or what we're going to call acceleration at that point, okay, that are going to be pointed towards the center of some imaginary circle that were made. We're going to find, if you remember, that the acceleration vector was 90 degrees, right, at any given point perpendicular. But let's go to this other question here. So is it possible to move with a constant velocity, but not a constant speed? Well, I would say not, right? So using the same logic as before, right? You could say if velocity is constant. Oh, Joshi asked for another explanation of why displacement is 0 in this case. So Joshi, let's check this out. Again, if we go back, I'm going to go back real quick before we talk about this, just because I really want to answer this question. It's a good question. So let me see if I have that previous slide here. Yes. So one more back. Here we go. So remember in this case here, right? It's very similar to this case here, right? Displacement was 0 and running around a lap because, well, we essentially start and stop at the same point. Maybe I need to go back one more slide to get this fully, right? And that was the idea that the displacement is just the difference in the start and the finish. It's just the difference in the start and the finish. So if you run a lap in a circle, you start and stop at the same point. And the shortest line between where you start and stop is a line of no length, right? So even though you did in fact run a giant circle, right, you had no change in your displacement. The interesting thing about this, it's not that, again, that you didn't have any distance that you ran. It's just that all the directions canceled out. When you run in a circle, the displacement vector of each moment is like the hands on a clock, and they will eventually all cancel out, right? So this is really noted when you get to uniform circular motion. It becomes fairly obvious. But that's a good question for sure. You definitely want to be sure as to what informs these principles. You can't just say it unless you see it as well. So it's very key that we notice that displacement was 0 here, because we start, and I'll even note that here for those of you at home that maybe didn't see it, we start and stop at the same point. Okay, now back to the whole, like, why does the speed, like, is it possible to move? I should probably put my yeses in my no's here, by the way. So I'll put a yes here, I'll put a no here. So is it possible to move with constant velocity but not constant speed? So if velocity is constant, then its magnitude is constant, right? And if its magnitude is constant, well, that's the definition of speed, right? That is speed. And I'll just say equal to speed here. You could say i.e. speed, et cetera, et cetera. So it's important that you note that, again, always derive these justifications from definitions, from equations that are given, right? Because these are the relationships that you're allowed to utilize. You can't just say, you can't just be clever, right, and kind of jump to conclusions. So as much as we try to, or as much as we can, we try to limit that, right? All right, last thing I want to talk about real quick. Sorry, it's a windy day outside. I see things flying around. I have to twerk my head over. I don't know if some of you guys saw the storms that were moving across the southeast. I'm on the tail end of that, though. Let me go ahead and bring in some information on the acceleration. So it looks like we're probably not going to get to the majority of our content today. It's okay, though, because we had a lot to talk about when it came to what's going to be on the test, or what changes were being made to the test. So you can rest assured that as we get new information about the test, that'll come to you. But the majority of the physics sessions are probably going to be heavy in the content side of things with this high-level overview. But I did mention acceleration earlier, so let's make sure we cover that. Acceleration is going to be the change in velocity over the change in time. Notice that we did, in fact, say just the change in velocity, not the change in speed. Okay, so the change in velocity over time represents the acceleration, delta v over delta t. Now, because it's a change in velocity over change in time, it's a meters per second, which we give the derived units of meters per second squared. And I got a question here from Justin. So velocity, essentially the displacement over time, delta x, very good. And it shows direction and thus a vector quantity, whereas speed is just the magnitude. Couldn't have said it better myself, Justin. Excellent summary there. Excellent. Absolutely. And I wouldn't use the word just, right? When you're writing your AP test, never use the word just. but I know exactly what you mean by just. It's solely the magnitude, right? Absolutely. You can totally get away with that. So acceleration, since it includes velocity, if you include a vector quantity, you're going to need to be a vector quantity yourself. There's some exceptions to that where we have two vectors coming together and we just look at the cross product or dot product with them, right? But we won't go there. All right, so this is going to be acceleration, since it's a change in velocity, will be a vector quantity. Because we saw earlier, right, that we could have changes in the velocity without having changes in the speed, right? So we could have changes not in the magnitude, but in the direction, right? And that would be an acceleration that we would call centripetal. All right. We got just a few minutes here, so I'll kind of, bring up a few questions related to acceleration, and then we'll close it out with just a reminder of some of the resources that are available to you, because I want to make sure you guys have those going forward. But just some easier questions per se, right? We have a car traveling in a straight line along a highway at a constant speed of 80 miles per hour for 10 seconds. Let's find its acceleration. Well, again, the acceleration is just going to be a change in the velocity over a change in time, right? Which would be a v final minus a v initial over a t final minus t initial. If you wanted to do it that way, right? You're more than welcome to. It really gets to the point of it. So here's the thing. this car is going a constant speed for 10 seconds. So its final and its initial are the same thing. The more astute amongst you must have noticed, right? And this is the time is 10 minus 0. We had 10 seconds traversing. The more astute here, and I probably should have included my units here, obviously, right? If I'm writing this out correctly, so my apologies. But more astute notice that this is indeed a 0, right? 0 meters per second. There was no change in velocity over this change in time. Anything divided by, or 0 divided by anything is equal to 0 itself. So this is 0 meters per second squared if I'm going all the way with it, right? Straight line at a constant speed. And it was important to note that it was a straight line, right? Because if it wasn't, we'd be having a change in direction, which would be having a change in the velocity. All right, in the second example, the car is going along. Oh, is there any surface in this world that is 100% frictionless? Well, yes, exactly. We're talking, in physics and chemistry, we often talk about a perfect world, an ideal world, right? So in this case, an ideal world has nothing to do with social order and more to do with whether or not we include friction or non-conservative forces, right? To go back to that original statement I made about the big picture of we want to talk about conservative forces in the cases of elastic potential, and gravitational potential, electrostatic potential, right? We can get into all these things. But we always assume there's no friction. We assume 0 friction. So 100% frictionless, if you want to say it that way, absolutely. Real quick on this last example. So the acceleration of this car, it's going in a straight line at a speed of 20 meters per second, but then it ends up, right, at a speed of 32. So this delta V over delta T will be a V final minus V initial over T final minus T initial, right? So this is going to be 32 minus 20, forgive the units here. And then 3 seconds later, so 3 minus 0. So in this case, I have a 13 over a 3, right? Which I could leave it as 13 over 3 technically here and say, leave it as my irrational here, and say meters per second squared. Okay, that was its average acceleration because it covered some range of time. Note that you could also have, right, instantaneous acceleration, right? Instantaneous accelerations as well as velocities. So keep that in mind. That's where we usually draw an arrow to indicate their direction when they're instantaneous. I want to thank you guys for coming out. I'm going to go ahead and bring in that those resources again for you. Remember that the AP website is your friend and Princeton Review is your friend. I'm your friend, even though we just met. I know I just give my heart away so easily, right? Let me see if I can get another whiteboard up here for you. Oops, I don't know. Maybe not. Let's just go back to one of the earlier slides here. Not that far back, or not far back. All right. So again, my name's Will. Here's my email. I recommend that you guys take advantage of all the College Board resources and all the Princeton Review resources. There are practice problems up on College Board's website. They have all of their webinars and meetings posted, so you can get into the minds of these people. Think like the grader. Remember, this is a mile long and an inch deep, right? So you don't have to know these esoteric facts. You need to know a little bit about everything and then hone your practice accordingly. I want to thank Brian and Tyle for helping me out today, for keeping you guys in check with all the questions. And hopefully I'll be seeing you guys in the near future for some other AP physics sessions. So thank you very much and have a wonderful day, y'all.